Okay, so we talked about how if you take the general quadratic equation ax squared plus bx plus c equals 0 and you complete the square with that, you derive the quadratic formula, which looks like this. Now we're just going to look at a problem where we apply the quadratic formula, we use it to solve a quadratic equation. So you've got 2x times x minus 3 equals negative 7. So if we multiply this out, we're going to have 2x squared minus 6x equals negative 7. So it is a quadratic equation, and we want to get everything on one side because you cannot use the quadratic formula until you have moved everything to one side. Get it in order with your x squared term first, your x term second, and your constant third, and then have it all equal 0. So this, your x squared coefficient is your a, the negative 6, the coefficient on the x, is your b, and the 7 is your c. So when you plug all of this into the quadratic formula, you're going to have the opposite of negative 6, which is 6. So negative b plus or minus the square root of b squared. Negative 6 squared is 36. B squared minus 4 times a, which is 2, times c, which is 7, all over 2a. So 2 times 2. And that's going to be 6 plus or minus the square root of 36 minus 56 all over 4. And you can see that you're going to have a negative number under that square root. It's going to be negative 20. And so you're going to need to use Euler's notation to deal with that. So I'm going to go ahead and break this up into the real part, 6 over 4, plus or minus the imaginary part, square root of 20i over 4. And 6/4 is 3/2. And then you have plus or minus. Remember, the square root of 20 can be reduced to 2 times the square root of 5. And that's over 4i. And if you reduce that fraction, your final answer is going to be 3/2 plus or minus the square root of 5 over 2, and then I. So this is in your A plus BI form that you want to always leave your answers in when you have a complex answer. So those are the solutions to this quadratic equation: 3/2 plus the square root of 5 over 2i, and 3/2 minus the square root of 5 over 2i. And complex solutions to quadratic equations always come in conjugate pairs. There will be times when it is useful to know the number and types of solutions a quadratic equation has. In these cases, you don't really need to find the solution. You just want to know how many solutions are there and what kind are they. And to find that out, you can just use what is called the discriminant. That is the value that is under the square root sign. And the reason you can do that is because if you find out that the value under the square root, the discriminant, is equal to 0, if that number is equal to 0, then your solution is just going to be negative b over 2a. You won't even have that part of the solution. So there will only be one solution to that equation if its discriminant is 0, and it will just be a real number. It'll be negative b over 2a, which is a real number. So if b squared minus 4ac for your whatever quadratic equation you have comes out to be 0, then you know you just have a negative b over 2a for your solution, which means one real solution. So if your discriminant, on the other hand, turns out to be greater than 0, if you end up with a positive value under the radical in the quadratic formula, you know you're going to have two real solutions because the radical is a real number this time, but you still have negative b plus or minus whatever that number is. So that's a real number. So there are two real solutions if the discriminant is positive. So if b squared minus 4ac is positive, you know that you have two real solutions: negative b plus some real number over 2a and negative b minus some real number over 2a. So two real solutions if the discriminant is positive. If the discriminant is negative, which is what just happened in the problem we just did, we know we're going to have two complex solutions because we're going to have negative b plus some imaginary number over 2a and negative b minus that imaginary number over 2a. So two complex solutions. Let me just repeat that. If you have a quadratic equation and you want to know how many solutions there are and what kind they are, you can just look at the discriminant, b squared minus 4ac. If it turns out to be 0, you know that equation has one real solution. If it turns out that the b squared minus 4ac is positive, greater than 0, then you know you're going to have two real solutions. And if the discriminant turns out to be negative, less than 0, you know you're going to have two complex solutions. So if we wanted to use and that should say discriminant, not determinant. We are not talking about matrices here. So discriminant. I get those two words confused sometimes. Use the discriminant to discover the number and types of solutions for each equation. So the first equation, a is 5, b is negative 3, and c is 1. So b squared is going to be 9 minus 4ac. So 4 times 5 times 1. That's your discriminant, 9 minus 20. That's a negative number that is less than 0. So this is going to have two complex solutions. You just use the discriminant when you don't really care what the solutions are. You just want to know what kind and how many. This one, you've got to get everything on one side before you can find the discriminant, and you've got to get it all in order. So I'm moving everything to the left side so that on the right side I just have 0. So here a is 2, b is 6, and c is negative 3. So b squared minus 4ac is going to be 36 minus 4ac. And you can see that that's going to be 36 plus 8 times 3, which is 24. And that is greater than 0. So we know that this equation has two real solutions. And then on the last one, again, we have to get everything on one side in order and 0 on the other side. Here, your A is 4, your B is 12, and your C is 9. So your B squared minus 4AC, your discriminant, is going to be 144 minus 4 times 9. And so that is going to be 144 minus, which is 144. So that equals 0, which means there is only one real solution for that equation. So that is how you use the discriminant. You use it to find how many and what kind of solutions a quadratic equation will have. That's all it's really good for. Solving an equation for a specified variable, you're going to have some equations where you just have to isolate one of the letters, one of the variables, and this is just some problems that involve practicing that. Okay, for this one on the left, you want to get r by itself, so you've got all multiplication here on the right side, so you just need to start dividing by things to get them out of the way. So you can divide by 1/3, which is the same thing as multiplying by 3. So if you multiply both sides by 3, that'll be dealt with. So you'll have 3v over there. Then you're going to divide by pi, and you're going to divide by h, so those are gone. And that'll leave you with r squared on the right. To get r by itself, you're going to need to take the square root on both sides. You would normally put plus or minus, but since you know that r is positive, you can just put the square root of 3v over pi h is equal to r. You don't need to put plus or minus because r is greater than 0. And then you're going to need to rationalize this. You're going to have to multiply. This is the square root of 3v over the square root of pi h. And to rationalize that, you're going to need to multiply by pi, the square root of pi h on the top and the bottom. And so that is going to give you the square root of 3v pi h over pi h, just to rationalize it. So on the problem on the right, you've got mt squared plus nt equals z, and you want to solve for t. Now there's no way to isolate that t except when you notice that this is a quadratic equation in the variable t. So if you get everything on one side, you got mt squared plus nt minus z is equal to 0. That's a quadratic equation. You can think of t kind of like as your x. So you've got t squared, you've got a t term, and you've got what we can call a constant term, that minus z. So to solve this, you have to use the quadratic formula. So m is your a, n is your b, and z, negative z, is your c. and you just plug all that into the quadratic formula. And so you're going to have negative b, which will be negative n plus or minus the square root of b squared, which is n squared, minus 4a, which is m, c, which is negative z, all over 2a, which is 2m. I know it gets confusing because now we're saying m is a, b is n. It's just kind of weird, but this is how it works out. So negative n plus or minus the square root of n squared plus 4mz, and that's all over 2m. And really, you can't really make this look any better than that. That's about as reduced as you can get it. Okay, so on this one, we want to solve for y. And again, we have a quadratic equation in y. So we've got a y squared term, we have a y term, and then we have an x term that doesn't have a y in it. So we treat this just like a quadratic equation because that's what it is. So 1/4 zy squared minus 5y minus x equals 0. So I'm moving the x over to the right side, and so therefore all of that stuff is equal to 0. My a, therefore, is the coefficient on y squared. So a is 1/4 z, or you could call it z over 4. The b is the coefficient on y, which is negative 5. And the c is just negative x because it doesn't have a y. It's just, we consider it the constant. So negative b, that's 5, plus or minus the square root of b squared, 25, minus 4a, which is 1/4 z, c, which is negative x, and that's all over 2a, so 2 times 1/4 z. And we can simplify this a little bit, but not a whole lot. 5 plus or minus the square root of 25. We've got this 4 and that 4 cancel, and so we have plus xz. And then in the denominator, we just have 1/2 z. And it's not really cool to leave a fraction in the denominator. So if we multiply the top and the bottom of this fraction by 2, we're going to have 10 plus or minus 2 times the square root of 25 plus xz all over z. And that's as simplified as we can get it. Don't think about trying to get that 25 out from under the radical because it can't come out because it's not a factor. Only factors can escape the radical. So don't even think about that. That's the best you can do to simplify that.